then we can move on to another geometrical definition. Okay, so just now we mentioned about tangent. When you do the differentiation, you get a vector tangent to the graph. Okay, so this is r prime is tangent to the graph. Okay, basically. So in this case, how to find the equation of tangent line? Okay, so here we know r prime is tangent to the graph here. In the depend on the how the direction of move, you can see that r prime direction in the increasing the parameter. So because this here is moved in this way, so you know that the direction of r prime is moving upward, right? So there's a point tangent to the graph, then r prime is tangent to the graph. Then what we're going to do is find the tangent line. Okay, can you find the tangent line? Okay, so we call it the tangent line. Okay, how to find tangent line? So in this case, we're going to talk about tangent line. Okay, this graph here. Tangent line got an equation. What is the equation of line? Okay, so let me see whether I can go this here. Okay, so usually equation of straight line we call, okay, something we call afterward we can do a lot of exercise is we call the equation of straight line. Equation of straight line in 3D, right? Because this is usually a 3D vector got I, J, K component. What is equation of a straight line in 3D? You have this equation something like this: R T equal to R0 plus TV. Okay, R0 plus TV. So what does it mean? R0 basically is a fixed point on the straight line. So based on this picture here, so this is a straight line. So somewhere here, this, if I going to pick a point, let's say this point is fixed here. Okay, this point is fixed here. Okay, I use this one. Okay, this one is fixed point. So I got a fixed point. Okay, this point R0 is a fixed point. What is it R0 here? Maybe we call it R0 is a R0 here. Maybe in this case is R at T0. Okay, R T0 is R0 here, fixed point. So this is a fixed point. And then what is V here? V is a direction of a straight line. So in this case, there is a vector V here, somewhere here. This is a V here. V. Usually, you can take this one, velocity, V, okay? Direction of straight line. So there is a V here, direction of straight line. Okay, here vector, right? Vector, direction vector. Okay, direction vector. Okay, direction vector of a straight line. So let me write properly here. So this is direction vector. Okay, direction vector. No need to be unit vector, but actually tell people this what is the vector, right? Direction vector. So equation of a straight line, if you want to find equation of this tangent line, you can find that, okay, what is actually here. So let me extend the straight line a little bit here. Okay, extend a straight line. You want to find the position of straight line at any time t. Okay, let's say I want to find position of straight line at any time t. Let me extend a little bit here. So, not very good. I want to join them together. Okay, so join them together. So not very good. So not very difficult to match them. Okay. Okay. So let's say I have to get what is the type at this point. What is RT from the origin? What is RT for this straight line? Okay. So RT is here. How people get RT here? So basically, you can draw two parts here. At the vector, RT is this vector plus this vector. So that's why you can see that RT here is direction of straight line, right? Equation of a line now is actually RT0, which is a fixed point, plus a multiple of V. Okay, because this green line is a multiple of V, right? So it's T plus multiple of V. Okay, so this is why you get R0, and then this R0 here. That's why you get R0 here plus multiple of V. Okay, equation straight line is this one, the blue one. Okay, is actually the green one. The yellow one first, the yellow one plus the green one. Green one is a multiple of V. That's why you got this equation. Okay, this is usually called the vector equation of a line. Okay, this is called a vector equation of a line. In this case, it's tangent line. This is called vector equation of a line. Okay, this is something you learn in AIM2, but probably you forgot already. So, the vector equation, okay, of a line. It's something you learn in AM2, maybe forgotten already. So you know the vector equation of line of three forms actually. When you learn one of them, this vector equation. Also have parametric equation. If you want, then write them in parametric equation. Okay, so this is how the vector equation of line. Then you can use parametric form. Okay, x and y and z parametric form. So after this, there are some differentiation rules follow. Okay, you can actually product rule. Okay, you can do a product rule for dot product, for cross product also have there. Okay, so this is product rule. Basically, one of them is, especially the second one, is product rule here. Product rule can also do for cross product and dot product. Okay, also valid for also cross product. You know better there are two types of product here and dot product. Later on you'll see that again. So I'll show you that the vector equation is this one, R0 plus TV. This is vector equation. The vector equation. So you can make it in the parametric equation. For example, this can be xt, yt, zt in terms of t now is equal x0, y0, z0 plus t of abc. Right? Let's say abc is the vector direction of tv. So you can say tv, t is abc now. Okay, so that means that x is equal to x0 fixed point plus ta. Then y is equal to y0 plus tb. and then z, in this case, is z0 plus tb, tc, right? So this equation is called parametric equation. Just like you did last time, or straight line. Okay. Parametric equation of a straight line. So from here, and then we can actually do a sample of this thing, right? We can know how to find equation of a straight line. Okay, so far very few fill in the blank, just an explanation of all these things, how to find equation of tangent line. So actually the thing we above here, about here, is how to actually use this to find equation of tangent line. Okay, so I have show you the equation of tangent line, how to find V, how to find R0, fixed point. Okay, and then we can look up for first example now. Okay, so first example already you have calculation will be example 2. Okay, hopefully this is right. Example 2, right? Okay, example 2, I have this example 3. Where's example 2? So example 2 is somewhere here. 3. Where's my example 2? Okay, example 2 missing already. Okay, my example 2 missing already. Yeah, my example is here. Okay, example 2. Okay, find the parametric equation of the tangent line. So I want what now? I have this thing here, parametric equation of the tangent line. Okay, of the tangent line. So don't confuse, huh? So parametric equation of the tangent line. There are two parametric equations there. First one is the original curve. Okay, so RT, we can write them. RT, for given to you, RT is equal to cosine T I plus sine T J plus T. Okay, this is not the tangent line. This is the parametric equation of the curve. Okay, this is parametric equation of curve. Okay, this is not really the tangent line. It's parametric equation of a curve. So how do you find the tangent line at the point t equal to pi? So the question I have is actually, I want to find the tangent line. Okay, parametric equation of tangent line here. So I want actually this equation of tangent line. Okay, so by this equation I want parametric equation of tangent line at the point t equal to pi. Okay, so how to do that? First of all, let's do a differentiation first. Okay, in order to get tangent line, you have to find a direction of a tangent line, which is equal to r prime first. So you find out r prime t. Okay, r prime t is equal to differentiate cosine, you get minus sine. Differentiate sine t, you get cosine t. And differentiate t, you get 1. Okay, then you put t equal to pi. So r prime t and prime pi now, you get minus sine pi I plus cosine pi j plus 1 k. I know sine pi is equal to 0, so you don't need to worry about sine pi equal to 0 here. Cosine pi happens to be minus 1. So this vector is actually minus j plus k. This is the direction of a tangent vector, okay? So vector tangent to the curve at t equal to pi. Okay, vector tangent to the curve at t equal to pi. This is minus j plus k. Now, what is this curve called? This curve is called circular ellipse. Okay, we have name for this direction of this curve because circular ellipse. How does it look like? It actually look like a circle, but it's not a circle in the plane. You move up the plane. So you find that this is something similar to ellipse here. So actually the movement of the curve, it looks like something like this. Okay, so let's give you a feeling of this one. Look like it's actually something like this. Go out there. Okay, so you move along the curve. You actually look like going into a circle, but it is not a circle on a plane. It's because they are move up. Okay, you move up. So this is called a circular ellipse, just like the diagram I show on the right there. Okay, so you can find out how this thing look like. What is it in increasing t direction? Okay, so I will going to show you this diagram again. Okay, and copy this diagram to the next page and then show you how people construct this graph. Okay, so the graph, you have x-axis, y-axis, z-axis, right? So where is the x-axis and y-axis here? So let me copy this graph here. Okay, copy this one. I'm going to move it to the next page and do right. Okay, so how do you look at this graph? So where is the x-axis here? So this one you can see that this is telling you that x equals 0 is here. Okay, so x equals 0 is here. Let me blow up a bit here. So I can adjust the size of the graph here. So solution 2. Roll out this one a bit so you can see clearer. Okay, so this is the circular ellipse here. So this is x equals 0. So basically the x-axis is actually this way. So let me show you. X-axis moving in this direction. So this is your x-axis here. This is your x-axis. So x equals 0 is the center, 1, and then 2, for example. Right? The other side is x equal to minus 1. then minus 2. So this is x-axis here. X-axis positive direction and move to the right. And then y-axis is actually which direction? So y-axis you get y-axis, you can actually show here. Okay, this is y equals 0. So you can get y-axis here somewhere here. So y-axis somewhere here, okay, y-axis here. So you want to draw y-axis, okay, let me, because the scale is difficult to see here, so I get y-axis here. Usually x and y axis are perpendicular. Okay, so x equals 0. Okay, x equals 0 somewhere here in the middle, origin. So actually it's not like that now. So let me, this x-axis actually I move here. So the center is here, 0 here. Okay, this x-axis here. This x-axis here, negative x direction. And then the z-axis is go from the ground. So this is the z-axis here, go from the ground. Okay, go from the ground here. Okay, so let's see how the point look like. So actually your point is RT equal to cosine Ti, okay, plus sine Tj plus Tk. Okay, this is the curve. Curve look like this. So when t equal to 0, where is it now? So t equals 0, you get cosine 0 I plus sine 0 j plus 0k, which is actually I 0 0. Okay, so this is a point at 1 0 0. Okay, so you can find that the x value is 1. Okay, y value is 0, and then okay, x value is 1, y value is 0, and z value is 0. So this is the point. Actually, let me see where 0 here. When t equals 0, you get 1 0 0. This, how do I get this one? This is 1 0 0. Okay, maybe I can redraw again. Okay, let's say this 1 0 0 here. X equal to 1, y equals 0, z equals 0. Okay, correct. You can see that your x equal to 1, value of y is 0. Okay, y is 0 here. Y is measured from here, right? So you can, y is measured from here. So this y equals 0 here. Okay, y equals 0. Z also, of course, is 0 on the ground. X equal to 1. Let's try to find out what happened when that is why you got this point here. Okay, that's why you got this point here. So let me, okay, this point here. How about when r equal to pi, r pi now, r pi, right? So this will be cosine pi I plus sine pi j plus pi k. So this is actually cosine pi is minus 1, sine pi is 0, and then pi k. So this is the point minus 1 0 pi, right? So at this point, t equal pi, this is the point here. You can see from the point, the x coordinate is -1. Okay, the x coordinate is -1. The y coordinate is still 0. Okay, and of course this is actually from the, if you look at it this way, it's actually here, y equals 0, and then the z is pi now. Okay, z is pi now. How far are you away? We'll move up the pi here, this pi here. Okay. So you have moved from one pi to another pi. This is how they move, and you get the tangent. From there, we find the tangent direction. The purple is a tangent vector. So purple one is a tangent vector here. Okay, tangent vector. Tangent vector. The purple one is a tangent vector. How the tangent vector move? You can see the direction. Always move in the direction of a curve. The curve model, so this is tangent vector now. Tangent vector is this way. Move in the direction of tangent vector. So now we slightly understand how the curve moves. This kind of curve moves. So I got tangent vector. I know already. I want to find equation of this tangent vector now. Okay, so I'm going to move again, move a graph again, okay, to show you. Okay, move a graph again to show you how to find the equation of a tangent vector. So I insert a new page here. So I'm going to copy this graph again. Okay, copy this graph again. And then we last thing on it. Okay, so I already know the direction of tangent vector is r prime pi. So r prime prime is v here. R prime pi. We find that this is equal to minus j plus k. Okay, minus j plus k here. So r prime pi is minus j plus k. Okay, actually prime here. So this direction is actually direction of minus j plus k. Okay, so what is the equation of the tangent line? So somewhere now is the origin here. Okay, so I join this one to here. This is R0. Okay, R0 to the point. Where is that point? We can calculate just now. Is actually minus 1, 0, pi. Okay, so this point is P0 here. Okay, R0 is actually minus 1, 0, pi. Okay, so if you want to find equation of this straight line, tangent line, okay, you want to find equation of tangent line, let's say this straight line here, continue. So you want to say, oh, where is the equation of this tangent line? Let's say I draw it here to the center, to the origin. This R T now. Okay, equation of tangent line. This RT now. Okay, RT. So RT is equal to R0 plus TV. Okay, so this is R0 is minus 1, 0, pi. V in this case is 0, minus 1, 1. Okay, because this 0, minus 1, 1 in terms of RJK. So this is your RT here, which can be of course equal to xt, yt, zt. Okay, this is equal to minus 1 plus t down 0, 0 plus minus 1t. Okay, so add them up. You can add it. So you can actually add them up first. So this one is minus 1 here. This one is minus t here. And then this one is pi plus t. Okay, when you add them up, minus 1 plus 0, you get minus 1. 0 plus minus t, you get minus t. Pi plus 1t, you get pi 0. So in terms of parametric equation, you get this one. That means that your xt here is equal to 1. Minus 1, sorry. Your xt equal to minus 1. Your yt equals to minus t. Your zt equal to t plus pi. And this is the parametric equation of tangent line. Okay, so these are the main point. Okay, main point of this example. So let me see, maybe I can WhatsApp to you to this example. This is consider one complete example. Okay, so let me complete this example for you, right? So I'm going to make this example as a complete example first. So this is beginning. I'm going to find the tangent vector, and then I blow up, okay, to find the point for you. Okay, how do you read the graph? And then how to calculate the equation of tangent line, especially the parametric equation, right? So the one you have, this one is called the first one is actually called the vector equation, right? Vector equation of tangent line. And then the last one you get is the parametric equation of tangent line. So I mean, if it is this one,